Hello everyone and welcome back to CPuzzles. Today we're going to continue on with operators 4.2. For those of you that are following along, we are doing puzzles out of the C puzzle book by Alan R. Feuer. Feel free to pause the video and try to solve operators 4.1 on your own before jumping back into the solution. Once again, here we have the snippet of code, the boilerplate from 4.1, nothing has changed. The only new addition that we have is this print macro invocation now with the expression being passed in x bitwise or y bitwise and bitwise complement z. So once again, operators 4.2, we have three integer variables, x, y, and z, which we've initialized to be 3, 2, and 0 in octal format, respectively. Nothing has changed from operators 4.1, so these integer variables and their values remain intact. Calling in the macro call, here we have our bitwise operators. We have the bitwise or, bitwise and then the bitwise complement, which is designated by this little squiggly line. So once again, which of these operator / operands do we evaluate first? If you guess the bitwise complement or the squiggly line, you are a winner. The bitwise complement has the highest precedence, and we can go ahead and confirm that by looking and inspecting our table here. We can see that in the second row, next to the exclamation mark, we have the little squiggly line, which is known as the bitwise complement. The associativity for the bitwise complement, note it is right to left. Applying that concept to our statement here, we can see that going from the semicolon, going from right to left, we hit the Z token first. And then after the Z, we have white space. So we're going to go ahead and munch off that white space to bind the bitwise complement to the Z token. And now that we have done this, the next bitwise operator that takes precedence is the ampersand here, the bitwise ANDing. Right, going back to our table here, we can see that the bitwise AND has a higher precedence than the bitwise inclusive OR, as we saw from the previous 4.1 video. Therefore, going from left to right in this case, we can see we're going to do the operation of Y bitwise with the negation of Z. And last but not least, this will be the result of this would be the right-hand side to the bitwise OR operation, with x being the left-hand side. Showing the operation of the bitwise complement, all the bitwise complement does is complement the individual bit values. By doing that, by replacing or complementing zeros to ones and ones to zeros. So in this case, z, which was initialized to a value of 1 here in decimal value, and this is the binary representation. Bitwise complementing z would give us, well, 1 complemented would give us 0, 0 would give us 1, 0 would give us 1, and so forth. So we can see that zeros have turned to ones and 1 have turned to zeros. So the resulting value of the negation of z is 254 in decimal. Passing that result as the right-hand side to the bitwise ANDing of y being initialized value of 2. Here is 2 in the binary representation, 2 in decimal. Once again, we have the negation of z, which is 254, and the binary representation. Bitwise ANDing bit by bit, we get 0 ANDed with 0 is 0, 1 ANDed with 1 is 1, and then the remaining bits are all 0 ANDed with 1, therefore anything ANDed with 0 would be 0, and the result of this would be 2. Now replacing that 2 here as the right-hand side to the bitwise OR operator with x being the left-hand side. X again was initialized to a value of 3. Here is the value of 3 in binary representation, 3 being decimal over here. Now performing the bitwise OR, bit by bit, we get 1 ORed with 0 is 1, 1 ORed with 1 is 1, and then we have the remaining bits, 0 ORed with 0, which will give us 0. So therefore the resulting value is 3. Going back to our print macro invocation, once again we have the expression here. which is replacement for the printf standard IO call. So by doing the stringization concept here, we're going to go ahead and convert this expression into a string literal. We have our remaining string literal with the percent specifier for print specifier for decimal format. And last but not least, the replacement list here being 3, which was the resultant of the whole expression here. Invoking this should give us something of the sorts of x bitwise or, y bitwise and, bitwise complement z equals 3 on the terminal screen. Let's go ahead and see if we get that output. Here I'm just showing you once again the code in VS Code here, showing that I've added a new print macro with the actual expression. Therefore, when we go ahead and try to execute and compile this code, using GCC as our compiler, let's see, and executing and running the executable, we can see that we get exactly this expression that we saw in the slides: x bitwise or y bitwise and bitwise complement z equals 3. Alright, thank you all for watching. Once again, to watch the previous video, click on the bottom left-hand corner. And to watch more CPuzzle programming content, click on the bottom right-hand corner and subscribe. Catch you all in the next video.